Minesweeper is an extremely interesting logic puzzle video game which has been around for at least 30 odd years, but still is engaging, makes us think, and it's fun to play. The objective of this game is to unravel mines inside these squares. So just imagine you are on some kind of a battlefield or something like that. These squares, some of them contains mines or bombs. We must not step on them. We must in fact find out where they are using hints that we get from the board itself. So for example, in the beginning, basically there's nothing is known, so I just take a guess. Let's say I try guessing here. It tells me there's one mine in any of the neighbors, which means one of these squares is a mine. I do not know which one. Let me just try my luck. Let's say I click on this here. Well, again, it tells me one of this is a mine. Now, if this happens to be a mine, then I know this is not a mine, but I wouldn't want to take a guess right now. Let me see if I click, let's say, this square, and now I get lucky. So notice what happens is something interesting. The entire field opens up, but the basic rule remains the same. It tells me, look, there is one mine, for example, near this square, I mean, in the neighborhood of this square, which means, let's say, this square has to be a mine. Given that this is a mine and this is a one, this is not a mine, so I take my chance here. Okay, so this is not a mine. It means that this is also not a mine, because notice this square is just one neighbor, and hence I can go and play this. Again, this is not a mine because this has only one. Then I click on this. There are two mines here. Okay, so I know this is a mine, this is not a mine. Now let's say if I look at this square, okay, so I can't still be sure. Let me, however, go here. So I know this is a mine, which means this is not, which means this is not, which means this is not. Reason is because this is one here, so this is a mine, this is not a mine for sure, right? Now I've come to this point. Again, this is a mine, this is not a mine. This must be a mine because there's a one over here. So it has to be a mine on this. And if this is a mine, that means this is not a mine. In fact, this has got four. Let me think about this. So this is a mine. This square here tells me, and in fact, this square here tells me that this and this both must be mines, which means this is a mine, this is a mine, this is a mine, this is also a mine because this square has got four. So I'm kind of making progress here. Let's focus our attention here. This has to be a mine because 1, 1, 1. So this must be a mine. Now, given that this is a mine, this cannot be a mine. So it also tells me once, which means this cannot be a mine either. This cannot be a mine. Okay, so I get some help here. Again, I get a situation where this has to be a mine, which means this is not a mine because this was a 1. Given that this is the 1, this is not a mine. This is not a mine either. In fact, this is a mine and this must be a mine too. So in fact, I'm almost done. I will take my chance to say that this is not a mine. And that's not a chance, it's a logical guess because remember this was 1. There's a mine here, so the neighboring squares are not mine. I tried my luck, the field opened up. And now basically I know that this is a mine because again 1, 1, 1 here, which means this is not a mine, which means this is not a mine. And notice I have unraveled all the mines in there. The game is now over. Using the clues given in the game, I have in fact opened up the entire minefield and I know where the mines are. Now, if you look at, let's say, other, examples of Minecraft, now if you look at other examples of Minesweeper, you'll realize that the field can be bigger, there can be more mines, and basically that adds to the difficulty level because many more things to solve. What happens, however, if you do click on the mine? Let's see. So let's say if I play the game again, now again mines are going at random locations, so I don't know where the mines are, but let me just try my luck. Let's say I try, the top left corner. Wow, that was really lucky. Notice the entire field has almost opened up. I know this is a mine. I know this is a mine because notice this is 1 here, so this has to be a mine. This is 2, which means both of these have to be a mine. So I leave these alone. I know this is a mine, which means I know this is not a mine. This is not a mine. This is not a mine. So that's 2, 2, 2. Okay. I know this is a mine, this is not a mine, this is not a mine, this is not a mine. I was hoping things will open up. In fact, this is not a mine. Okay, this is also not a mine because again, this is a 1 here and there's already a mine over here. So really, um, getting a little bit confusing, but I can say that okay, this is for sure a mine, and this is a mine, this is a mine, so this must not be a mine. Let me try to sort of maybe try my luck and see if I can open up again. Oops, unfortunately, I clicked on a mine and you notice the game is over, indicating that I have lost. So basically the point is, if you click on a mine, then you lose the game immediately. Otherwise, the board guides you to find out where the mines are. And basically, that's what you have to do. You got to find all the mines. Now, this is our next activity in the YByte Python curriculum available at www.ybyte.in. We will create an interface like I just showed you, like a 9x9 Minesweeper game with 10 mines randomly sprinkled. But of course, all of this are, customizable. So I can have maybe a bigger minefield, lesser mines or more mines. It's up to us. We will keep it configurable. Our game will follow all rules of Minesweeper, which I was showing you. However, we are not yet building the flagging feature where the player can flag a mine. They say that, okay, look, I think this is a mine, I'm not sure. This actually is helpful while solving the puzzle, but it does not change the game outcome. The game rules remain the same. Of course, we can sort of explore this as a bonus idea. Engaging and interesting as Minesweeper is, let us also try to answer how does this align with the curriculum? What are the learning goals from this activity? Well, first and foremost, we are going to continue working with two-dimensional lists in this project, basically lists of lists. We have built a game Connect 4, which had similar ideas. We are going to take that further here and, again, revisit, let's say, indexing on two-dimensional lists, the pertinent points about initializing them, avoiding shallow copy, and using, in fact, let's say, logic over these two-dimensional lists. We will revisit the grid placement method. Basically, those buttons will be placed using the grid placement method, grid placement manager of tkinter, because they're all nicely arranged. We will do something very interesting, which is a recursion over a 2D grid. So basically, this is kind of extension of a two-dimensional list programming. We will build this recursion, and the part we do with recursion is the point where, as you saw, the field completely opens up. When I click on a cell or click on a square which does not have any, let's say, mines in its neighborhood. Now, obviously, to put it all together, we require fair amount of programming logic. So we will, as always, organize our code in functions. We will use for loop, break statement, global statement, list methods, in fact, lambda statements, and so on. A bunch of things are going to come together in this. It's going to be a fun journey. And as always, we'll do this in a step-by-step manner. Broadly, the steps that we follow, well, we'll first set up the grid of buttons like we just saw using the tkinter grid placement. We will define and populate two lists of buttons, which is a list of tkinter buttons. Remember, in Python, we are able to create lists which are very interesting. For example, previously we created list of turtles. Here we are going to create a list of tkinter buttons. So button object will be put in a list, and that becomes quite useful later on. We will use another list called field, which will be a list of integers that store information about neighbors. In fact, this is the sort of the crux of the game, the backbone of the game. That's how it basically works. We'll place mines randomly. This is interesting because remember now we got to sprinkle things in a two-dimensional minefield, and we'll see how we can do that in a very efficient manner. We will write a function to find neighbors. This again is very interesting to me because we will write a function in a way that is quite neat and takes care of the different scenarios that come up in a very unified manner. Having done that, we will update our field list with neighborhood info. Again, very interesting because there are multiple choices of doing this. We will choose one of them, and we will, proceed with the code to do that, and we'll see how it goes. Now, having done all this homework, we'll set up the gameplay. Basically, ask question that okay, look, what happens when the button? As we saw, if the button is a mine, the game gets over right away. If the button is a square whose neighbor is a mine, then we are told how many mines are there in the neighborhood. And if the button is one of those which is, let's say, doesn't have any mines as neighbor, the entire field. Now this happens through recursion, and that is the final step in developing this game. We will discuss in detail this function open up. Very, very interesting. How the whole, recursion comes together, how it runs, and also the base cases. How does it stop? So we'll have a detailed discussion on this. Again, like I said, we will do this in a step-by-step manner, systematically analyzing every point, carefully looking at the different options and proceeding with the code. I think it's, as always, our curriculum is available at www.yby.in. We believe in learning by building interesting activities, analyzing them in detail, and understanding, building them in a step by. That is exactly what we are going to do with this project as well, starting from the next video. Take care. Thank you so much. Bye bye.